Hello students, welcome to the next session of the DSP. Here we are going to consider the next point, that is recovery of an analog signal. This is nothing but like a reconstruction of an analog signal from its sampled format. So since it is the sampled format, obviously we need to take for the equation number 4, which we have seen, or rather the earlier part. From equation number 4, x of f, which is nothing but x of f equal to 1 upon 2w. W is nothing but the maximum frequency component of analog signal. So summation equal to minus infinity to plus infinity x of n by 2w e raised to minus j fn by 2w. So from this equation, if I want to calculate, let's say, x of t, I need to take the inverse Fourier transform. So that is what done in the next stage. X of t is equal to inverse Fourier transform of x of f. So it will be taken like this. Once we have written it, for finding the inverse Fouriers for this particular statement, it can be further split like it will be integral minus w plus w 1 upon 2w summation n is equal to minus infinity to infinity x of n by 2w. This term is simplified because 2 is getting cancelled over here, e raised to j by ft. So with respect to integral is taken. So that is df. Now, next line, simply the simplified format of the same equation is mentioned. Means here the summation is simply separated out along with the integral terms. Okay. So this is simply the rearrangement of the e raised to j f into t minus n by w. So it is again with respect to f itself. So integral with respect to f. Now further, the expression can be simplified. Let me just count it within the region. Okay. Summation part, I will just try to put it over here. This is the summation part. X of n by 2w into 1 upon 2w. Let's rearrange by finding the integral for this term. So after integral of this one, it is nothing but e raised to j theta theta. So integral will be e raised to theta itself divided by theta. E raised to theta, theta means e raised to theta by theta. So that is what done over here. This part will be simply divided. So finding the integral, apply the integral over minus w to plus w. So after application of the integral, this part is, let me just concentrate because the other part is quite same. So here w and here this will be simply multiplied here. 1 upon j 4 by w into 2 minus 2 by n minus n by w. So after this next portion, this is simply by applying the integral minus w and by putting the value plus w. So plus w minus this minus of minus w. So this is how the integral will be simply applied over here. So that is why the sign e raised to j term, that is negative. Now from this further simplification of the same part, let's keep this summation and x of n by 2w as it is. It is not at all varying since the first term or the first part of this proof. Here e raised to j 2 pi w is simply rearrangement of the first part, t minus n minus n by 2w into e raised to minus and rest of the terms are same. This is recalling the term related to the sine theta. So it is nothing but what e raised to j theta minus e raised to minus j theta divided by j. So the same thing is done over here. After that, once we have simplified this term, let's check it. Here, the summation will be as it is. This is nothing but sine of what? Theta over here is 2 pi wt minus n pi. So after rearranging the term, this is what the format. 2 pi wt minus n pi. Now this is nothing but what? Sinc function. So sinc x is nothing but what? Sin pi x by pi x. So since it is nothing but overall sinc function, it can be simplified further like x of t is equal to summation n is equal to minus infinity to plus infinity x of n by 2w sinc 2wt minus n. Let's call this as equation number 5. From equation number 5, it is quite clear to us that requires an interpolation formula for reconstructing the original signal x of t from the sequence of sample values left, which values x of n by 2w. Sinc function plays the role of an interpolation function. So this is like a interpolation function over here. Each sample x of n by 2w is multiplied by delayed version of sinc function. So that can be observed over here. Each value x of n by w, delayed version of sinc function. This is delayed version is getting multiplied. So this is how you can say the reconstruction can be done, and it can be easily obtained from equation number 5. So this is all about the reconstruction. Thank you everyone. Thank you very much.